Hello, this is Professor Zaman. Welcome to Hasan Zaman educational video series. This video is in our DC circuit series. In this video, we will discuss DC parallel circuits. Let's begin. Resistors in this circuit will be in parallel. So let's begin with a very simple circuit. Let's say we have a battery, 12-volt battery, and we have 3 resistors. Okay, let's assume this resistor is 2 ohm. This is 3 ohm. This is 6 ohm. Okay, let's name them also. Let's assume this is R1, R2, this is R3. So, to find the current of this circuit, let's first find the current through the battery. And to do that, we can find the equivalent resistance of these 3 resistors in parallel. And the formula for finding out the equivalent resistance of a parallel set of resistors is this. The total resistance, or you can say call it R equivalent, equals 1 over plus R1 finally plus 1 over Rn, assuming there are n resistors. So in this case we have only 3 resistors. So it will be 1 over 2, 1 over 3, 1 over 6, 18, so it will be 9, 6, 3, 18 over 18, 4 over 1, 1 ohm. So we found the resistance of this circuit, total resistance is 1 ohm. So if we redraw the circuit, this is still 12 volt and this resistance is 1 ohm. This is R equivalent, and this voltage is positive volt, 12 volt at the top. If we assume this is the ground node, then we can find out that this voltage will be also 12 volt. Here, the positive on the top, that means higher voltage at the top side, and at the bottom it is lower voltage, which is 0 voltage actually. This is called as IT, total current. So IT is 12 volt by 1 ohm. Okay. So we can say that this voltage is also 12 volt is across these 3 resistors, because this is equivalent resistor of these 3 resistors. The voltage between this point is 12 volt. And this current is IT is equal to 12 ampere. Now, what will be the currents through these branches? We can apply Ohm's law. The voltage across this set of resistors is 12 volt, and this is very important. We have to remember this. In a parallel set of resistors, all the resistors have the same voltage across them. So this 2 ohm, this 3 ohm, and this 6 ohm, all of them have 12 volt across them. So if we apply Ohm's law on this resistor, the voltage across it is 12 volt, and resistance is 2 ohm. So the current through will be, this will be 12 by 2. How much? 6. 12 by 2 is 6 ampere. And again, voltage here is 12 volt and resistance is 3 ohm. So this current will be 4 ampere. And this current will be 12 volt by 6 ohm, 2 ampere. If we sum them up, 6 plus 4 is 10 plus 2 is 12. Must be equal to the total current that is coming in here. And this is actually an important law we'll discuss in another video called KCL, or Kirchhoff's current law. That is, at any node, the amount of current coming in will be equal to total amount of current coming out. So 12 ampere coming in and total 12 ampere coming out at this node. And same will be true here. It's coming in 12 ampere and 12 ampere going out. But we will discuss that in another video. One other thing we need to look at here, how we can find this total resistance in an easier way. So that to do that, we will look at two other forms of this formula to find total resistance, because that will make our life much easier. We'll look at a couple of special cases. So a special case one. If we have only two resistors, what happens? Then R equivalent will be 1 over R1, the R equivalent equals to R1 times R2 over R1 plus R2. We also call it product over sum. This is really important. For example, you see here, this is 3 ohm resistor and this is a 3 ohm resistor, this is a 6 ohm resistor. If you want to find the equivalent resistance of these two only, we can use this. What is the product? 3 times 6 is 18, and what is the sum? 3 plus 6 is 9. So 18 over 9 is 2 ohm. So the equivalent resistance of these two resistors is 2 ohm. And we could do that without even writing anything on the board, just knowing product over sum. Now this is 2 ohm and these two combined 2 ohm. What is the total resistance? Now 2 ohm and 2 ohm is again product is 2 times 2, 4, and sum is 2 plus 2, 4, 4 over 4, 1 ohm. So without having to write all these things, we could easily find out the total resistance of these three parallel resistors is only 1 ohm. There is another special case we need to look at, that is equal resistors. Suppose, so a special case equal resistor. So So in that case, that formula will come down to R equivalent 1 over R. Let's say all of them are equal to R. R 1 over R, so it will be 1 over n by R, n over R, because there are n number of resistors, and that equal to R over n. So this is a very important thing to remember. If you have equal resistance values, then the total resistance is resistance of one branch divided by number of branches. So a lot of things to notice here. Remember, we found out the equivalent resistance of these two were only 2 ohm. Now when we are trying to find the total resistance, what we did next, we took this 2 and this 2 and we applied the product over sum rule. You didn't have to do that actually. What we could do is saw there are two resistors equal value, so the resistance value, equivalent resistance would be value of each resistor 2 divided by number of branches 2 over 2 1 ohm. So this is a little bit simpler than using even the product over sum. So these are the three things. We always try to use either this or that or a combination of them to find the total resistance of a parallel set of resistors. Because applying this, you need really to start with a notebook and pen and do some calculation. But with these things you can solve even without using any calculator or a notebook. Now, a few things to remember here or observe here. The total current is 12 ampere, and let's see which current is the biggest current in these three branches. You see, the biggest current is 6 ampere, and that is flowing through the smallest resistor. That means the smaller the resistance, the higher the current, because all of them have same voltage. And the next higher resistance is 3 ohm, and current is a little smaller, 4 ampere. And the highest resistance is 6 ohm, and current is the smallest through it, 2 ampere. And there is another important thing to remember, that the total resistance in this case of the parallel resistors is 1 ohm, and which is the smallest, smaller than the smallest value of these three resistors. So this is very important. The equivalent resistance of a set of parallel resistors will always be smaller than the smallest value in this set, because you are providing alternate paths, parallel paths for current, so the resistance will be reduced. Just like on a roadway, if you have parallel roads, then cars have multiple ways to go to the destination, and there is less jam on the road. So this is the opposite of the series case. In the series case, we saw that the total resistance is sum of the resistors. The total resistance is bigger than the biggest resistor in a series case. In a parallel case, the total resistance is smaller than the smallest in this set, and the current is always highest in the smallest resistor, so, and lowest in the biggest resistor. And another important thing to remember, we mentioned before, the voltage across all of these resistors are same, which is 12 volt. Now we will look at another thing. Some people use it and they call it a special rule. It's called current divider rule. In a parallel circuit, or where the resistors are in parallel, the current is divided. As you see, the 12 ampere current is being divided into three branches, 6 ampere, 4 ampere and 2 ampere. And altogether there is still 12 ampere. The current is divided, and the current is divided in the inverse ratio of the resistors. The higher the resistor value, the lower the current. So if you find this voltage like we did here, 12 volt, then you can find individual current very easily. But suppose don't want to find the voltage. In this case it was easy because this voltage was applied voltage. In a complex circuit, this voltage will not be equal to the applied voltage. There could be other things in the circuit, they will also drop some voltages. So let's look at that special rule people use, current divider rule, or CDR. So this applies to a parallel circuit. So let's call this current I1, this is I2, and this is I3. So what is I1? I1 is this voltage, let's call this voltage V prime. Okay? V prime is 12 volt. So V prime divided by R1. Now how do we find V prime? V prime can be found by multiplying this current IT times the total resistance are equivalent. Keep similarity, let's also call this RT. Okay, RT is equal to R equivalent. So by applying Ohm's law, you can say this voltage is I times R, that is IT times RT. RT and R equivalent are same thing, and R1, so you can say RT over R1 times I2. And if you find out I2, it will be RT over R2 times IT. So in general, you can write IN is equal to RT over Rn times IT. So this is the current divider rule. So for example, if you want to find out I3 times IT, RT is 1 ohm, R3 is 6 ohm, and IT total current is 12 ampere. That will give us 2 ampere, which is same what we found before. So same thing, if you could find the voltage, then you can use Ohm's law to find the individual currents, or you can directly find the current without having to find the voltage across them. You just need to know the total current flowing into them. People use this law to find current in parallel resistors. Now there is a special case for this. If there are only two resistors, say a special case, two resistors, then what do we have? We have, suppose for two resistors it will be let's find I1 first. I1 will be RT by R1 times I total. And for two resistors, what is the equivalent resistance? We found out just a minute ago, that is product over sum, which is R1 times R2 over R1 plus R2, and at the bottom is R1 times IT, R1 times R2 over R1 plus R2 times R1. R1 and R1 cross out, it becomes R2 over R1 plus R2 times IT. This is very useful because suppose you had only 2 branches in this case. So let's make that simplification. Let's erase this, and suppose you had only 2 branches. R1, R2, this is 3 ohm and this is 6 ohm. So what will be the current I1? But you have to know the total current. So let's find that out. So there are 3 ohm and 6 ohm in parallel. So equivalent resistance is, by using the product over sum, 3 times 6 over 3 plus 6, that is 18 by 9, 2 ohm. 12 by 2, the current will be 6 ampere. Now if we apply the current divider rule, I1 will be, so for I1 you have to write R2 at the top and at the bottom R1 plus R2. So R2 is 6 and divided by 3 plus 6 times 6, it will be 6 by 9. So 4 ampere, and I2 will be, using the same, when you are finding I2, you have to write R1 at the top. Okay, so it will be R1 over R1 plus R2 times total current. It will be, R1 is 3 plus 6 times 6, it will be 3 over 9, so it will be 2 ampere. Okay, actually you could find I2 in another way. The current here is 6 ampere coming in and I1 is 4 ampere, so that means the remainder of 2 ampere will flow through R2. So this is called current divider rule. This is the general form and this is the special form for only 2 resistors in parallel. So hopefully this video was useful. As we practice more with more circuits, they will be more clear to you, and we will also do more practice with this topic. Thank you for watching. Bye.